Here, let's find out what kind of mood I'm going to be in after this class. It's what? It's sunny?
Probably won't be warm though, so just wear a jacket and you'll be good.
Sunny in 52 is not bad. That's what it is? It's sunny in 52? Oh, I can... Oh, this is 53. All right. So I have to golf real quick right after class because I have to come back for a meeting this afternoon. Yeah, you're getting away. Seriously. All right. So we are writing a dice roller. So we're going to go ahead into Atom here. And I'm going to create another class here inside the same file. Right now we're going to still live within the single file of our code. Sooner rather than later, we'll probably start having multiple files. Maybe one file that had our player class in it, another file that has our dice roller class in it. But let's take one step at a time. So I'm going to create a class called dice. Okay. And then we're going to create a constructor for this guy. So this idea, this guy called a init. What's the job of a constructor? Talked about it last time, because remember, programming languages, they attempt to mimic the way we solve problems in real life. Okay, so whenever we're trying to figure out how to do something, we always want to think about how we might solve this problem in real life. Now, you know, truth be told, sometimes the solution to problems in computing isn't the same as real life, but it's probably a reasonable lens to pass, or a reasonable filter to pass things through initially, in case it is. I think more often than not, the way we solve problems in a programming language is pretty close to the way we would solve it in real life. Okay, so last time we talked about if we were going to build a house, which we can all agree a house is a real object, right? If we were going to build a house, we might hire a constructor, okay, a contractor to come out and build that house for us. And that constructor might need some materials from us, need some sort of input. You know, the easy version of it might be they say easy, but the quickest path of least resistance version is to just give the constructor money and he goes and builds a house for you. Now, you might also be somebody who already has a whole bunch of the materials, so you might give him some money as well as some existing material. Stuff like that, all right? So the constructor that we have for an object is the guy who's in charge of doing the initial building of the object, setting up any variables, filling them with some default data if that's required, that kind of stuff. All right, now for a dice, we're going to construct this guy with a number of sides that he's going to have, right? Now, technically, it's not called a dice, it's called a die. D-I-E, but that sounds funny. It's hard to say that over and over again. So we're going to have a single dice, and then we can have a set of dice. Right? It's going to be okay. So what we'll go ahead and we'll say is we're going to have our constructor, so underscore init, underscore. So this is kind of the initializer. That's the constructor in a Python program. We take in this first variable called self, which is always required. What is self? Remind me what self is again. Go ahead.
Self will refer to the specific instance of an object.
Okay.
Whatever will refer to the dot whatever attribute or method.
Okay, why do we need self?
So
what would we do if we didn't have self?
Have an existential crisis.
Okay. So I usually say something along the lines of self is how an object refers to itself from within itself. So all of us, we can refer to ourselves as I or me or my, right? Those are all things that we might say. What if you weren't allowed to use those things? You're going through life and you're not allowed to use those words that directly refer to yourself as yourself. Then you do that weird thing like, you know, well, Mike is going golfing, right? That kind of thing. Now, the people do that, right? But it's kind of supposed to be funny. So if we don't have a way of talking about ourselves, we kind of lose part of our problem solving, don't we? If I'm saying I am going golfing versus Dave is going golfing for somebody else, that has two separate meanings, correct? So we do lose part of our problem solving when we don't have a way of referring to ourselves from within ourselves. And when I say I, and when he says I, those mean two different things. My variable for referring to him is he. Okay? His variable for referring to himself is I, because he doesn't have the variable he internally. All right, this kind of makes sense. This is related to real life. So self is how an object refers to itself from within itself. This is how it talks about itself. Later on, when we create an instance of something, we have a variable P1, which is a synonym for P1's variable called self. So P1's variable, named self, is going to have the exact same value internally, inside of that player, as P1 has externally to that player. Okay? So self versus one of you pointing at me and saying Mike mean the same thing. They're both talking about the same person. It's the same memory address, right? We just have two different ways, two different pointers to that memory address. All right, so our constructor is going to take in self, which is just a required syntax of Python, and then it's going to take in a number of sides. And we're going to go ahead and we're going to create a local variable called sides, and we'll set that equal to the number of sides that came with it. Now, these guys right here, let's open up the keynote again. I don't think we actually we just started talking about self and wrote some stuff. So we talked about constructors, talked about self. Let's just talk about object members. So all objects are made up of constructors, fields, and functions or methods. All right, so fields, these are variables owned by the object. Constructors, these guys initialize the object. Functions allow objects to perform abilities or something like that. Okay? So all objects are collections of these things. They have at least one constructor. They can have 0 or more fields. Usually they're going to have at least one field. An object's going to remember some piece of information. And then they might have, they can have 0 or more functions, but most objects are probably going to be able to do something. Okay? In this case, in our dice roller, we're going to have our dice object. He's going to be able to roll, which is going to be related to the number of sides he has. And he's going to have a field called sides, which is going to know how many sides that guy has. So if we went to the gaming store and we brought back a 6-sided dice or a 20-sided die, that guy it's like the instance of our dice object with that number of sides. And if we roll a 6-sided die 20 times, each time we're going to get a value between 1 and 6. If we roll a 20-sided die 20 times, each time we're going to get a number between 1 and 20. Because that's the nature of that particular instance of a dice. That make sense? All right, so in this example here, we have exactly one field, sides. We have our constructor. And then we're going to go ahead and we're going to give ourselves a function called roll that won't take any wrong language. That won't take any parameters except self, which is a required parameter. Okay? And what do we want this guy to do? We want him to go ahead and roll the dice within a certain range. We want it to roll between 1 and sides inclusive. All right, so we're going to go ahead and we're going to return random.randint. And this takes a range. The range is going to be from 1 to self.sides plus 1. Because self.sides would be non-inclusive. All right, so if sides was 6, I'm going to say give me a value between 1 and 7, not including 7. That will give me a number between 1 and 6. That make sense? All right, so that's our whole dice class. We build a dice, we tell how many sides, and now he can roll stuff. And each time he rolls, he returns a random number between 1 and the number of sides plus 1. or 1 in the number of sides, including the number of sides. So we can test this guy now. So let's just comment out this guy. So we'll go ahead and create a dice. D is equal to, wrong language. D is equal to dice. We'll give this guy 6 sides. And then we'll say for I in range 0 to 10, print D dot roll. All right, so we'll go ahead and roll the dice 10 times. And each time we should get some number between 1 and 6 in this case, because it was a 6-sided die. So, oh, wait a minute. It is inclusive. Okay. If you added 1 to it in your homework, I won't take anything off. I just assume this worked the same way as range worked. Because range goes from a value to an end value, not including that end value. Apparently, randint gives you this number to this number, including this number.
I just looked it up, and there is a rand range function
that works the way okay.
Yeah, it does work.
That's fine. So we came back from Home Depot. We had this tool, messed around with it a little bit, and realized it works slightly differently than we thought, but pretty close, right? So this will roll a number between 1 and sides, including sides. So we didn't need to add 1 to it. So there we go. That looks, we got a bunch of 3s there in a row at the beginning. All right, good enough. And then if we want to, so we might call this guy D6, and then we might have another guy D20, and this guy is dice 20 sides. So maybe we roll the D20 10 times. Now we should get values between 1 and 20. Look good. And if we want to have a D100, oh. Sucked and hit the lottery at the same time. Okay. So first of all, are we seeing how much power we have now with objects? I mean, we created this little class, kind of a variable of our own type, and now we can just create various versions of this guy to solve different problems. If we need a 6-sided die, if you're playing a board game and you need a 6-sided die, you can just build a 6-sided die. If you're playing a tabletop role-playing game, you need a 20-sided die, you have your 20-sided die, whatever it is. Make sense? Okay, so now what we can do is we can decide inside of player how we're going to figure out hit points. So maybe a player has associated with it several dice, okay, that it uses for solving different problems. Okay, so maybe a player has a dice collection, all right, and maybe the dice collection allows him to roll a certain number of sides for different things. So we're going to go ahead and we're going to say, let's give him maybe a D20 for hit points. So we'll say self D20 is equal to dice of 20 side. And then maybe a self maybe a D8 for damage. So we'll give him two different dice, a D20 and a D8. So for his hit points, instead of giving a random number there, we'll say self.d20.roll. And that'll roll his hit points between 1 and 20. So this guy might be really, really weak. Correct? We certainly could add a little to something to it. We could say +5 to guarantee that he has at least 6 hit points, but let's not. Right? Some people are just going to be born extremely fragile. Okay? It's just the way it'll go. So when we display ourselves, we'll do the same thing we did before. When we inflict damage, we're passing in an amount of damage. When we receive damage, we're receiving an amount of damage. is dead returns whether or not your hit points are less than or equal to 0. And then in fight, when it's your turn, we are calculating the amount of damage. So we're going to do damage now as a D8. So we'll say self.d8.roll. And that'll get our damage. Okay, so let's go back here. All right, so we have, oh, I actually held up pretty well there, given the discrepancy in, I guess, initial robustness. So we, all right, so in any case, we seem to be fighting okay here. Now, what are some things that we might want to do as part of a, I guess as part of a fight? When you're playing a game, sometimes you want to have some sort of user interaction, right? So you might have potions. So we're going back. How many of you have played the game Final Fantasy, like the original, old school Nintendo Final, well, or something relatively recent? Okay, where you so these are turn-based games, right? Because in Python with a text-based screen right now, we're probably not going to be doing a real-time shooter. Okay, so we're going to do a turn-based thing where it might ask you, okay, it's your turn to attack. What do you want to do? You got some options, right? You can just do a normal plain Jane attack. Maybe you have a magic attack and you only get so much magic. Okay, maybe you're about to die and you want to use a potion to hopefully survive one more round, right? So for right now, let's not add in the magic stuff. Let's just have two options. We can either attack or we can heal ourselves. All right, in hopes of living, and if we think we're going to kick the bucket on the next round. All right, so we're going to have to. We'll just start with a generic version of this. Well, we'll just say whenever we heal ourselves, we heal for what, maybe a D6 worth of health, something like that. We try to heal ourselves. We roll the dice, and we get healed for 1 at the minimum, or a maximum of 6. Hopefully it's not a 1, because then we've kind of wasted our turn. Okay, so we're going to have the ability to heal, but in order to do this, we have to have user input, correct? And Python 3, what do we use for user input? Is it just the input function, or is it raw input?
It's input.
Just input. Okay. So when we do a fight, depending on whose turn it is, right now we're just defaulting to an attack. We don't want to do that anymore. Now we want to ask, what do you want to do? Does that make sense? All right, so let's go ahead and let's get some user input. We'll keep it all inside this fight function for right now. So rather than just haphazardly rolling damage, we're going to give ourselves a D6 up here. So we have the heal dice. So we'll do a D6. I'm just naming it D6. So that's kind of common naming for different sides dice. So this is a 6-sided dice. So now we have that guy. Now notice in a strongly typed language, you would have had to predefine all these variables like up here and then give them values in here. In a loosely typed language like Python, there is no such thing as predefining variables. So we just say, oh, we're going to have a name. So we're going to set my name equal to name. We're going to have a D20. We're going to set that D20 equal to a new dice built with 20 sides, so on and so forth. Make sense? So this is kind of the nature of a loosely typed language versus a strongly typed language. So next semester, when we write the same guy in Java, we'll see that there are a lot of similarities, but there's going to be some differences there in terms of us having to predefine our variables as opposed to just expecting them to exist whenever we want to use them. Okay? So we gave ourselves a D6 because we decided that might be helpful. And with that in mind, let's go ahead and give ourselves a couple of functions here for getting damage and getting healed. And so we're going to do get melee damage and then get, I don't know, get health pot or something, something like that, which will provide us the correct amount of data. That way, if we decide to modify this later on, we can just go and modify those couple of functions rather than hunt and peck throughout our code for all the places where we might be rolling for damage or healing. All right. So inside of a player will know how to get melee damage. And melee damage is you're just, either, I guess, using your fists or swinging blunt weapons. Not magic. Okay, we'll have lightning bolt damage later, which will be greater, right? Greater damage, but maybe a bigger range, something like that. So maybe in the if the way a video game might work is your melee damage might be 5 to 9 damage, but lightning damage might be 1 to 16, something like that, where it's a chance you might fizzle, but could hit pretty hard. All right, so get melee damage. We're still going to have to take in that variable self, and we'll go ahead and return self.d8.roll. We'll just roll 1 through 8 right now. That's what we've been doing for damage, or that's what we're going to do for damage. And then get health pot. We'll return self.d6.roll. Make sense? So that'll be our health potion. So if we want to get some melee damage to inflict on the other person, we'll have to ask our function to get melee damage, which gives us however much melee damage we have decided it gives. Later on, we might have different weapons. So one guy might have melee damage based on a broadsword or something. Another guy might have melee damage based on a dagger, which might be a different amount of melee damage. And then health pot, same thing. We can decide there might be different levels of health pots, but right now it's just very simple. I'm going to hit you, or I'm going to help, or I'm going to heal myself. Okay. So these are the two functions that'll get us that stuff. So when we go and when it's somebody's turn, we need to ask that person, what do you want to do? Do you want to attack, or do you want to heal? Right? So we're going to go ahead and we need to be able to show the menu for attack versus heal. And so let's go ahead and give ourselves the ability to show a menu. Def show menu self. So you're kind of seeing the pattern here where we really modularize our code. We give ourselves all these little abilities. Okay. If I want to read some input from the user, what do? We show the menu, get the input, return the answer. If we want to get some damage, what do? We get some damage. We want to get some health, what do? We get some health. And we get the health pot. So we break our problem down into these little tiny widgets. So it's just like going up to one of those soda machines in Taco Bell or something like that, where you dial in a drink, right? You can say, okay, I want this soda with this flavoring in it and all that stuff, and then the ice never works and all that stuff, right? Okay, so yeah, that type of thing. So effectively, we're building that little machine. Now, this is a skill in and of itself, because there is a such thing as maybe creating too many individual methods. You get too granular where you try to do too little in each individual method or function. But then you don't want to err on the other side where you have this monolithic method that does 15 things, when really you should probably divide those 15 things maybe into 5 different methods that each do 3. Okay, unless those 3 things are divisible. Because when we think about actions that an object might perform, you want to think just like in real life. Okay, in real life, if I want to pick up this remote, one of the actions it requires me to do is to squeeze my hand, right? Grip my hand. Now, when I do that, that's the same action for picking up a remote. That might be the same action for zipping a zipper on my laptop bag. But those are 2 separate actions, right? So I might want to write that function that allows me to close my hand as an individual function, because I can now then apply that action, apply that ability to lots of different problems. There are lots of different solutions. Does that make sense? So this is kind of how we might think about it in the programming world. Think about it. This action we're currently writing, is this an atomic action that this is the only time we're ever going to do it? Or is it something that could potentially be applied to lots of different things? If it could be applied to lots of different things, you probably want to write it by itself. Okay? If it's only applied in this one scenario, and it would never make sense for it to be applied to something else, save yourself the trouble and put it in there with 2 or 3 other actions so that you don't have this like tiny little function that does something that's basically worthless except for this one problem you have to solve. That makes sense? Okay, so think about this the same way as you might solve a problem in real life. So for showing our menu, we're going to ask the user, what do you want to do? Do you want to heal? Or do you want to heal or hit? Heal or hit. All right, so maybe we give them numbers for them to enter in, a 1 or a 2, something like that. 1 to hit, 2 to heal. All right, we could have them type it out, but 1 and 2 will be easier to type. So we need to prompt them first. So let's see, input comes with a prompt, does it not? So I think we can say something like, we'll say option is equal to input. What would you like to do? 1 to hit or 2 to heal. Something like that. All right, and we'll go ahead and get our option, and then we're going to return that option. Now that option is going to get read in as a string. So if we want to be able to deal with it numerically, that's fine. But in this case, we don't. We just need to compare it to the string version of 1 or 2. So we'll go ahead and return the option here. All right, now before we do anything else, I just want to test something here. Let's just make sure that that guy, I'm going to do print p1 dot show menu. Let's just make sure it shows the menu, reads in my result, and returns it, just so I'm remembering how the input function works. What would you like to do, 1 to hit or 2 to heal? So I'll press 1, it should print out a 1. I'll run this again, I press 2, it should print out a 2. I can type in whatever I want, it'll just spit it out. So let's just assume we're using our program the right way. And I'm going to go ahead and at the very end of this, I'll put a little colon with a space after it, so give you a little separator. Okay, so in our fight, if it's this guy's turn, we're going to ask what he wants to do. Now, for us right now, it's just going back and forth. We haven't really given these guys, well, I guess they do have names, don't they? Yeah, Mike and Dave. So, if it's, if it is self's turn, so player 1's turn, in this case Mike's turn, we want to ask him what he wants to do. All right, so I'm going to go ahead and I'm going to say, we'll say print self.name. And then we'll say self dot, let's do action equals self dot show menu. So we'll say Mike, and then the next line will say, what do you want to do? 1 to hit, 2 to heal. And we'll read that in, and we'll do something depending on what the action is. So we'll say if action is equal to a 1, then we want to do damage stuff, right? So we'll go ahead and calculate our damage. We will then inflict that damage on our opponent. Then we'll display our opponent. And then toggle whose turn it is. Now, we will always toggle whose turn it is, regardless of whether we heal or hit, right? So I'm not actually going to put that under that if. Now inside my else here, and actually just to be explicit, why don't we say, oh, we'll say else for right now. So inside my else, that means action was equal to 2. I need to go ahead and get the amount we're going to heal for. So we'll say heal for self.d6.roll. So that'll be an amount we're going to heal for. Then we're going to apply that to our hit points. Okay? Now, let me ask you this. Should I write self.hp is equal to self.hp plus heal? Or should I put that into a function? And why? Should I write a function that says get healed, that takes an amount to heal this person for, this player for, and then he increments this guy's hit points? Or should we just write it right here, like this? Defend your answer. Keeping in mind that the last few minutes we've had a discussion about put things into methods that might need to be used multiple times. You got it?
If you make like forget your function and you just do this and the script so
Okay, fair enough. But let's expand it even a little more, thinking about it from like a game perspective. A lot of our games today are like multiplayer stuff. I mean, we're obviously only going to take this so far, right? But the idea is if you and I are on a team, all right, and we're fighting, he's a boss, okay? Dave over here is a boss. All right, I know you're not Dave. Okay. So he's the boss. Now maybe you're our fighter and I'm our healer. Okay, you're quick, and maybe I can carry lots of potions, all right, something like that. All right, so it's not inconceivable that during the fight I might choose to heal you, right? So now I'm not drinking the potion myself to heal myself. I might be casting a heal spell on him or using a potion on him, whatever it is. However we decide healing works in our made-up world here, but it would be beneficial for me to generate an amount of healing power and ask him to heal himself with that. Okay, with that in mind, having a get healed method might be beneficial because now players can get healed regardless of the source of the healing. Does that make sense? Now, that isn't something that we're supporting right now, so really we can go either direction with this. We don't have to write that function. So let's just leave it like this for right now. But that's the type of thing I'm talking about that we might choose to do differently. All right, so if we chose to heal, then we're going to generate the amount we're going to heal. We're going to give ourselves some more hit points, and then we're going to maybe we do this. We do something like print healing, something like that, and then we go ahead and say self.display, which will show our updated hit points, something like that. Okay? Oh, thank you. All right, so that will show our updated hit points. So we're either going to attack and do what we did before, or we're going to heal and do something a little different. In either case, it will be the other guy's turn when we're done. So this turn equals turn plus 1, I've actually put outside of the if else. Does that make sense? That happens regardless. It doesn't matter whether I decided to hit or whether I decided to heal. It's going to be the other guy's turn when we're done. Okay, so I don't need to, I shouldn't put that in here or inside the else because we want it to always happen. We don't want to accidentally say, well, I'm allowed to heal and then still attack again the next turn versus, well, if I hit, then it's the other guy's turn. That would be kind of cheating, right? So we're always going to relinquish our turn here. We'll go ahead and steal these first couple of lines. If it's the other guy's turn, we'll go ahead and print out his name. But his name is player.name. not self.name. My opponent. Then we'll go ahead and read in the action. Now we're both sharing a keyboard. Okay, so we're kind of buddies, even though we're fighting. So we're sharing a keyboard here. We don't have that two different controller thing going on yet. So we'll read in the action. If the action was 1, then what are we going to do? We'll get our damage. We'll have that player inflict damage on us. Then we'll display ourselves, showing that we've been hurt. Else, we're going to heal. And we'll say player dot HP is equal to player dot HP plus heal. Then we'll print out healing. You can do the healing, print out healing beforehand too. It doesn't matter the order, where this is all behind the scenes, right? Generate random number, apply random number to your hit points. The end user hasn't seen anything at this point. So then we're going to actually show something to the user that we're healing, and then we're going to have the player who did the healing display himself. And then take turns. Flip to the other turn. That make sense? All right. So now we'll have our players fight each other. But as we go through here now it's an interactive fight. It's not, not just going to automatically run through till somebody dies. Now it's going to give us choices what we want to do as we go through here. And let me just kind of talk about that for a second. So this menu thing, show menu, because this waits for user interaction, this guy does something called blocking. Blocks until the user enters their action. That make sense? So this is called blocking code, or code that blocks. It pauses the program until we can continue on. All right, and that's so we don't really have great context for that right now, because that seems like, well, that makes sense. But if we imagine a more complex software application, Microsoft Word or something like that, might we want to do one thing while something else is happening? Like maybe, let's say you're uploading your document to OneDrive or something like that. Okay, or to Dropbox, some cloud thing. And, you have slow internet. So let's say it's going to take 2 minutes to upload the document. Lots of pictures. Okay? During that 2 minutes, you don't want to have to sit there and twiddle your thumbs. You'd like to be able to keep being productive in Microsoft Word, and, maybe you're putting your headers and footers in or something like that. So you don't want that action to upload to OneDrive to block. Instead, you want that guy to happen, but you want it to happen inside of its own thread. So it's executing over here, but it's not blocking you. It would be a non-blocking call or an asynchronous call, which allows you to then keep doing something else. So that's an application that, in that case, has 2 different execution threads. The main execution thread that is, I'm using Microsoft Word, and then the secondary thread that does the uploading to OneDrive without taking attention away from us. Under the hood, if you have an older processor, like a single core processor, where most of our machines today have at least dual core, if not quad core or more processors, in a single core processor, your machine can literally only do one thing at a time. But we can be faked out. So even though in a single core processor, even though the system is technically only uploading or paying attention to us at any given point in time, the fact that that processor can do things so quickly, it might be giving the upload process a couple of microseconds, then giving us some microseconds, then giving this guy some microseconds, and from our perspective, it's happening fast enough that when we type stuff, it feels like it's real time. Does that make sense? But in our modern machines, I don't care, I would say everybody in here has at least a dual core processor in their computer. It has to be a pretty old computer to not have a dual core processor. I mean, you look really old, older than even if you perceive your computer's old. It very likely has a dual core processor. So technically, your machine can do two things at once because it's like you have two workers, right? You have one guy doing the laundry, another guy folding, that type of thing, and those are two separate workers. All right, so that's where blocking versus non-blocking comes in. But in this case, we're thinking about user input. We can't continue until the user enters stuff. We can't say, okay, well, the user can take their time entering stuff and we'll just move on without them. We kind of need that input in order to make the next decision, right? So let's go ahead and run this guy. All right. Mike, what would you like to do? Okay, well, I have the upper hand right off the bat. 18 and 10. Technically, we're not giving ourselves a maximum number of hit points, so if I did heal myself, I can become even more powerful than I began, but that's okay. I'm going to go ahead and hit. All right, so we'll hit. All right, so now, did we not get the display? So press 1 to hit. Now we show Dave after I hit him. So I hit him for 2. But it really should be showing us again, too. Are we not doing that anymore? Or are we displaying? Maybe what we'll do is we'll display the player. We used to do this every single time. Why don't we go ahead and display both people regardless? So this is outside that if and else. Doesn't matter whose turn it is. We're going to go ahead and, well, we're really doing this stuff right here. So we'll just put it right here at the top. So every single time we loop through our code, we'll give a little update on the current status of both of our people. Okay, this will happen right at the beginning, assuming nobody started off dead. And then it'll happen each time we come back through that loop. All right, so 19 to 6. Okay, we're going to hit. He didn't make it. Yeah, we probably need to have an exit. Show the after the death thing here. So that is inside the else. That's outside the else. Inside the while. That's outside the while. So when that while loop finally ends, we'll go ahead and display the final status. Who's standing over who? Okay. So what happened is you got one-shotted in that particular case. It wasn't pretty. I mean, you started off with only 6 hit points to begin with. Okay, I don't know how hard I hit you, but it was hard enough. Is what it came out to be. What's this? Yep. Ooh, this was going to be a tough one. Okay, I have to manage my hit points carefully. Okay, I'm going to take a risk here. So I'm going to go ahead and I'm going to hit. I'm going to have confidence that he's not going to destroy me the first hit. So I'm going to hit him. Ooh. It's like more like a little swat. Okay, I hit him for 1. All right, so we might be in trouble. Okay, what do you want to do? You're gonna hit? Okay, he's gonna hit. All right, I survived. I survived the smash. All right, so now I have 3. You have 13. Now it will probably be in my best interest now to go ahead and heal a bit, right? So I'm gonna heal. All right, so. Better than nothing. We're back up to 5 hit points. All right, so I assume you're hitting again? All right. Yeah. Yeah, he hit me for 7, and game is over. Okay, so it's didn't go as well as it looks like. I'm printing out self-display a couple times, but yeah. So it's kind of like that. But now we've added some interactivity to this. we can take it a step farther. We could start adding in magic or something like that. So give a 1 to melee, 2 to magic, 3 to heal or something like that. And then even within magic, you can then show more spells, right? You can do a fire-based spell or an ice-based spell, or you can summon like summon an animal or something, right? I don't know. Well, it depends what kind of like wizard you are. I mean, if you're like a druid type thing, you might summon an animal. But if you're like a normal mage, I guess it could be some sort of an elemental or something. I mean, I don't know, what were you thinking? You're the boss here. What kind of thing are you summoning? You're summoning an elemental. Okay, then you have too many hit points. Okay, because if you're going to be some kind of wizard here, right? Then you probably, maybe I'm a warrior, right? So I'm wearing, like plate metal, plate armor. Okay, he's this dude wearing like bamboo robes.
If he's one wizard, he's not going to be summoning. Let's be real.
I know a lot of games you can summon something. You get the little the mini elemental, like a sprite.
I summon candy.
You just have your sprite doing these death matches against like a bat or something like that.
Yeah, it's more likely to be like, well, maybe even if it's a small animal. It's not 5 seconds of spawn.
In those games, you have to do a special.
I know who you're going to summon next class. You're going to summon Mr. Gonzalez. It's a very high-powered magical spell.
What would his abilities be?
I don't know, but it would be powerful. That's what it would be. All right, so you don't want homework?
No. Ellie does.
Oh, Ellie wants homework? All right. If you're traveling for Easter, travel safely. I will see you when you come back, and we'll have an extra hard homework assignment first class back. Now, we're not back for this class on Monday. Classes resume after 4 p.m. on Monday. So if you do have an evening class on Monday, you're supposed to go to class. Okay, but during the day on Monday, classes are not in session. So the next time I'll see you is on Wednesday, right? All right, have a good Easter.